Hi, in this video we're going to do some practice problems with salt hydrolysis. So our first question says, what is the pH of a 0.25 molar solution of potassium nitrate? Potassium nitrate is KNO2. Now what is the pH? So to do this, we're first going to grab our salt, which is KNO2. First dissociate into K plus and NO2 minus. K plus is alkaline metal, so we already know that this has no dissociation for water, so we just cross it out. NO2, if we add hydrogen to it, it's HNO2. So this will be a weak acid, which makes it a strong conjugate base. That means this is basic. This solution is basic. Now that we know the solution is basic, we can write the new equation. Right up here, NO2 minus plus H2O makes, this is basic, so it has to the H, so it's HNO2 plus OH minus. Now with that there, we can set up a rice chart. So RICE. We're already told that the initial is 0.25 molar. This will be 0.25 molar over here. This water, we don't really care. This will be 0 and this will be 0. Now this will be minus x plus x plus x, because all of them have the coefficient of 1. This is 0.25 minus x. And this will be x and x over here. So this will be Kb. Now in this equation, we're dealing with Kb, since we're producing OH minus. And to find Kb, we must use the Ka of our conjugate acid. So Ka of HNO2, sorry, this is NO2, KaHNO2. So let's find HNO2 over here, 4.0 times 10 to the negative fourth. So this is 4.0 times 10 to the negative fourth. Now if we do Kw divided by Ka, which is 1.0 times 10 to the negative 14th, divided by 4.0 times 10 to the negative 4th. Now grab my calculator, 1.0 e to the negative 14th divided by 4 e to the negative 4th gives us Kb as 2.5 times 10 to the negative 11th equals x squared divided by 0.25 minus x. You move this over here to make a y equals equation. And if you do x squared divided by 0.25 minus x minus 2.5 e to the negative 11th power, and you go to graph. From here, you can find the x value, which is going to be x is equal to 2.5 times 10 to the negative 6. 2.5 times 10 to the 5 to the negative 6. What is our x again? Our x is the concentration of OH. So now that we know the concentration of OH, we can use concentration of OH negative log concentration of OH minus is equal to the POH. So let's do negative log of our x, which is 2.5 e to the negative 6, gives us 5.602. Now 14 minus 5.602 gives us 8.40. And now that is our pH for potassium nitrate. Actually, let's do one more problem. The question asks, what is the pH of a 0.2 molar solution of sodium carbonate? Sodium carbonate is NaCO3. What is the pH? So let's dissociate our salt real quick. CO3 turns into Na plus CO3 2 minus. Oops, Na2CO3. There we go. This is group 1, so we cross it out. It has no association for water. CO3, H2CO3 is not one of the strong acids. So this is a weak acid, which means this will be a strong conjugate base. Now this is a strong conjugate base. We'll know to use this into our new equation, which will be CO3 2 minus plus H2O. Now don't forget to add your state of matter, which turns into HCO3 minus plus OH minus. Since we figured it's going to be basic, so we know it's OH minus. Okay, now with that, we can set up our rice chart again. We're given with 0.2 molar. So 0.2 molar minus x, 0.2 minus x, 0, 0 plus x, 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 x. So we can do K, again, this time it's OH, so we're going to use KB. If you're in a solution that gives you an acidic solution, then you're going to have to use Ka. So watch over here. Kb is equal to x squared divided by 0.2 minus x. Now how do we find Kb? By using the conjugate base. So conjugate acid. So HCO3, what is the Ka for HCO3? Ka for HCO3 minus. K for HCO3 minus. Now H2CO3 is over here. So it'll be 4.8 times 10 to the negative 11th. I'll explain what is K1 and K2 a little bit after we finish the question. So just know that right now we're going to use 4.8 times 10 to the negative 11th equals 4.8 times 10 to the negative 11th. Now if we do Kw divided by Ka equals Kb, we can find our Kb as 1.0 e to the negative 14th divided by 4.8 e to the negative 11th, which will give us 2.08 times 10 to the negative 4th. Now if we use that, we plug that into the y equals 0.2 minus x minus 2.08 e to the negative 4th. So basically what I did is x2 divided by 0.2 minus x minus 2.08 times 10 to the negative 4th. Second calc, 0. And then we go to find the left and right boundaries to get x as 0.00635. Now that we know that, we can use negative log because x is the concentration of OH minus 0.003635 to get negative log 0.00635 to get 2.197. Now 14 minus 2.197 gives you 11.80 pH. Or you can do a faster way. When you're given this, you can find pH as 14 plus the positive log of concentration of OH minus. So let's try that. 14 plus the positive log of 0.00635 gives us 11.80 again. So pH is 11.80. Now let me explain to you what the K1, K2 is. So let's grab this again. Our previous equation is H2CO3. H2CO3 plus H2O. What will happen to this? Well, this will turn into HCO3 minus plus H3O plus. Now that will turn into, we can grab this and apply it to H2O again. Because remember, acids only donate protons one at a time. We learned this a few units ago, which will turn to CO3 2 minus plus H3O plus again. So now in this case, let's say you're given with X amount of H2CO3. In this case, we can use 0.2 for our purposes. Now, if you remember, what is Ka? Ka is this value over here. So this will be Ka1, and this will be Ka2. Now, how do we use it with these salt? So first, let's assume this is 0.2 minus x, which is 0.2 minus x. This will be 0, 0 plus x, x, x. Now, after you found the x, notice that HCO3 minus is now x value. So you will not use 0.2 over here. Instead, you will use x. Now, x, H3O plus, new value is also x. So instead of putting 0 over here, you'll put x because you already have some H3O plus. Now, with this, you're going to do the right sharp for the second time. You're going to look for the second values of the change to solve for the final equilibrium. Now, in this problem, we're using CO3 2 minus and CO3 2 minus and HCO3 minus. So which one of these include a CO3 minus and a CO3 2 minus and H3O minus? It's over here and over here. That is why I use K2 over here, which is 4.8 minus 10 times 10 to the negative 11. If our equation included, instead of a CO3 2 minus, it was a HCO3 minus, and instead of HCO3 minus over here, it's a H2CO3 minus, it will correspond to the products in number 1. And in that case, I will be using the Ka1 to solve for the x values. Thank you for watching.